Okay, in this video, I want to show you guys how to complete the unit circle with all angles in degree form and in radian form, as well as determining whether all 6 trigonometric functions are going to be positive or negative in quadrant 1, 2, 3, and 4. So we always want to start out with the 0 degrees, which is this little part right here, and we go counterclockwise. If we start from 0 degree and going counterclockwise, we are going to get positive degree angles. And of course, oppositely, if we were to start from 0 degrees and go clockwise, the angles are going to be negative. So starting with 0 degrees, we are going to go up by 30 degrees. So maybe we are going to have like a ray coming out this way. This angle here is called 30 degrees. And the equivalent radian form of 30 degrees is pi over 6. So this is something that you want to keep in mind first, at least for the first quadrant and the second quadrant. And then from 30 degrees, we are going to go up by 15 degrees more. So we are going to get 45 degrees. So this angle from, this angle from here to here, that's 45 degrees. And the equivalent radian form of 45 degrees is pi over 4. So hopefully you guys can see that. From 45, going 15 degrees more, we are going to get 60 degrees. So maybe it's going to look something like this. 60 degree. Equivalent radian form of 60 degrees is pi over 3. So the pattern of increasing the degrees is first we increase by 30, increase by 15, 15 again, and then increase back to 30. And then increasing 30. So from 60, increasing 30 more, we are going to get 90 degrees. So this angle here is a 90-degree angle. So it's just a right angle right there, but I'm not going to mark anything. So this right angle is going to be, let's see, how should I write this? 90 degree. And the equivalent of 90 degrees is pi over 2. Now from 90 degrees, we are going to increase 30 degrees more, which will give us 120 degrees. So this is 120. Let's flip it around. And the equivalent radian form of 120 is going to be 2 pi over 3. Like that. And of course, using the same pattern of increment, from here we increase, from here we increase 30, 15, 15, and then 30. From here we increase 30 and then 15, which will give us 135. So this is 135 degrees. And the radian form of 135 degrees is going to be 3 pi over 4. Using the same pattern of increment as shown in the first quadrant, we are going to go from 135, increasing 50 degrees more, which will give us 150. And so this is 150. And the equivalent radian form of 150 degrees is going to be 5 pi over 6. So let's see, increasing by 30, 15, 15, and then 30. So 30, 15, 15, of course we had to increase by 30. So we get this straight line angle right here, which is actually 180 degree. And the equivalent radian form of 180 degrees is just pi. Now with the first two quadrants cranked out, how are we going to complete quadrant 3 and 4? I am going to pick one of this angle at a time. And then what I'm going to do is that I'm going to go the exact opposite direction of the terminal side of the angle that I selected. So I select 30 degrees. And this is the terminal segment or the terminal ray, whatever you call it. And I'm going to extend this terminal segment in the exact opposite direction. By doing that, I'm going to have another angle from here all the way to here, Well, this angle is going to be 210 degrees. Why is that 210 degrees? Well, because one, using the same pattern of increments as shown in quadrant 1 and 2, we increase by 30, 15, 15, and then 30. So starting with quadrant 3, we also have to increase 30, 15, 15, and then 30. So that's one way to determine the degree of this angle. Another way is recognizing the fact that we have 0 degrees right here, but the exact opposite of that, we have 180 degrees. So we technically just take 0 degree and add 180 to it. We crank out the degrees of the opposite angle. So if we select 30, all we have to do is add 180 to it. We get 210. So this angle right here is actually 210 degrees. Well, that's for the degree form. Now, what about the radian form? All you have to do is that you take the radian form of the angle that you're selecting, which you use to sketch this opposite segment, and you just take its radian form and just add the radian form of 180, which is pi. So we take pi over 6 plus pi. That's going to give us 7 pi over 6. And of course, same pattern for increment, we increase by 30 and now we have to increase by 15. So this angle here, this angle right here is going to be 225 degrees. So of course, again, increasing by 15 degrees, 210 increasing 15 degrees more is going to give us 225 degrees. Well, what about the radian form of 225 degrees? All you have to do is that you select 45 degrees angle, which is this opposite, which is this angle in quadrant 1 right here that I selected to sketch this opposite segment of this segment. So take its radian form, just add pi to that. So pi over 4 plus pi is going to give us 5 pi over 4. Okay, and then same thing, we take this angle 60 degrees in the first quadrant and just sketch the opposite segment of it. Just from here all the way to there. So we form another angle. And of course, we increase by 30, 15, so we have to increase by another 15. So 225 plus 15 is going to give us 240. And the equivalent radian form of 240 can be found by taking the radian form of the angle 60 degrees, which is pi over 3, and you add the radian form of 180, which is pi. So pi over 3 plus pi is going to give us 4 pi over 3. And of course, same thing with this one. We increased by 30, 15, and 15, and now we have to increase by 30 using the same pattern of increment. So 240 increasing 30 degrees more is going to give us 270 degrees. And the equivalent radian form of 270 degrees can be found by taking the radian form of 90 that we're selecting and add the radian form of 180, which is pi. So pi over 2 plus pi is going to give us 3 pi over 2. And if you keep going into quadrant 4 using the same method that I used to complete the quadrant 3, eventually you'll see that your unit circle is going to look something like the picture at the end of this video.